Hey everyone, welcome again to Innovation Coffee. Robert, hey,
Alessandro, hey, how's it going?
good.
Yeah, thanks for having me here. So I'm told today I'm going to be introducing the guest.
You've got this on your plate today.
I've
I
got
mean,
this on my plate.
setting the guest, you introduce him.
All right, cool. So yeah, Alessandro, thanks for once again having me on the Innovation Coffee. I'm very excited about today's episode. We're going to be speaking with Tyler Baker from Foundries IO. He's an old time friend, an old time colleague of mine. In fact, I think he's one of the first people who ever showed me about anything Linux. So I mean, I remember being back at the Embedded Linux Conference, ELC in San Diego. First time I got to hang out with him personally, and he showed me all sorts of cool stuff. I'm gonna have some cool questions for him. I think Alessandro has some good stuff for him. So let's bring Tyler onto the call.
Hello.
Tyler.
Hey. Thanks for having me. I'm really excited about today's episode.
Yeah, us too.
All right, where do you guys want to start?
It's really cool to have you on the show. I'm excited.
This is fun. I've watched the episodes before, and I've always been like, oh, it'd be really fun to get on there, talk to you guys, show some demos. I mean, that's kind of what we do.
Did you bring demos?
I brought demos. When do I not bring demos, right?
I know, right? Yeah. So we'll have to save some time at the end, Alessandro, for those demos. How much time do you think you'll need to show us a couple cool things?
Like 5-10 minutes is probably all we need. I can go longer if we have space to fill, but yeah, I mean, somewhere in that range would be fine.
Cool. So I think I'll kickstart this one, if you don't mind, Alessandro. I think it's really cool because you've been around the block. When we start getting into these conversations, everyone's going to start hearing how much Tyler's actually done here. But I'd like to kind of hear your origin story. So like if you could kind of tell us, where you started and where you are now in a nice little 2-3 minute elevator pitch, that'd be great.
Yeah.
Or take a little longer if you have to.
No, I think I could do it in 2 minutes. So yeah, my background's in product development, specifically around embedded Linux devices. So I worked at a couple of industrial companies before I ever made my open source debut. So I really understand what it takes to build hardware, to do hardware revisions, to do the software for those revisions of hardware, to ship it to customers, and to maintain it in the field for 20 odd years. I mean, we had products that we maintained for 20 years, and so it gives you a good idea of what it takes to ship something at a quality where like big companies, that's kind of where their quality benchmark is. So from there, I actually got an offer to go and join Linaro, and this was when Linaro was very small. And so if you don't know much about Linaro, they're kind of the open source version focused on Linux on ARM, and they had a lot of great, early canonical folks, a lot of people from ARM in there to seed the company, to kind of stand it up and make it what it is today. And so I think I came in as an employee like 31 or somewhere in there. So pretty early on, and instantly kind of was, I don't know, I was thrust into this open source world where I had sort of collaborated before, but I hadn't really, didn't really understand what it meant. And so at Linaro, I learned all about how to work with people all over the world, work remotely, how to contribute properly to open source projects, and then kind of what the ARM ecosystem needed and where the gaps were. And so I formed a project called Kernel CI with a few other members at Linaro, and that actually just became a Linux Foundation project. And it's all around testing the Linux kernel on a whole bunch of ARM hardware and other platforms to make sure that what we upstream is going to stay running, and it's going to stay enabled, and it actually works when it's up there, and so that encourages people to use upstream software. So from there, we kind of spun out a research and development team out of Linaro, and we called it Foundries.io. We've been going for about 3 years now. And so we're just getting to the point where we're making some really good product progress, and we're focused on updatable, secure embedded systems and helping our customers build those into products. So that's kind of the elevator pitch there, all over the map.
Yeah.
So from product development to open source to product development again. So
I've got a question for you following that journey, right? So you've seen a lot of development happening all around, all the different markets. And you're really big on open source, right? And I was going to ask you, how does it, well, first of all, I guess, what does innovation mean to you? And then kind of on top of that, how does perhaps open source enable innovation?
Yeah. So That's a good question. So I think there's two parts to that. So part of innovation is not going and building the foundational pieces yourself just because you want to. So that's where I think open source comes in, is that these open source pieces are providing foundations for you to kind of stand on the shoulders of giants, right? Being able to leverage the Linux kernel with all its hardware support, with all the contributors and eyes looking at that source code base. It would be really bad if you just went out and did your own kernel for just any old reason, right? So leverage open source, and to build off of open source is kind of the first part of innovation, I think. And then the second part of it is solving hard problems that customers need solutions to. And I think this is where the innovation part is really kind of realized, in the sense that you want to push the envelope so that it makes people uncomfortable. So you're trying to solve a solution in a way that makes them uncomfortable, because you're challenging the status quo. And that's where I think real innovation happens. And you can look at it like Elon Musk. I don't want to compare myself to Elon Musk, but he's really pushing the limit with electric cars, right? And what we can do with our space programs. And it makes people uncomfortable a little bit. Like, hey, we've always been told electric cars can't be done like this. Well, here's somebody that's doing it, right? And it's this drive and this knowing where the industry needs to go and pushing hard on a solution that you believe is going to get there. And so if you have an innovative product, people usually push back on it, right? The first time they hear it, because it's different than what they know. And I think taking open source, being able to build on top of it, and then pushing it into areas that make people uncomfortable, or maybe using it in ways that, hey, we don't do things like that. That's kind of where you start to see that innovation, because it forces people to change their thinking around kind of what they've been doing and what the future is going to hold. Thank
you for that insight. I was going to ask you actually something, I guess, follow up on that.
Sure.
What is the status quo in the embedded world right now? What do you see? So you talked about how we need to push innovation or push the boundaries. What is the boundary now?
Yeah, that's a good question. I mean, I think honestly, largely it hasn't changed in the last 20 years, and we're just starting to see it change. So you would take software, open source software, proprietary software, there's a mix of that, and you'd create something and you'd flash it on devices, you build your hardware and you'd ship it out there. And then maybe you have an update solution, maybe you don't have a root of trust, maybe you do. It kind of depends on, what the goals are. And so you have this thing where you just redo that entire cycle of developing, testing, shipping, deploying a product. And it's this monolithic process, and it costs a lot of money. I mean, a lot of engineering money. And kind of what our pitch is at Foundries is that there's only a subset of these engineers that can do this kind of work. And so how do we scale this out to the next, 10 trillion devices that need to be deployed in the IoT space? And so we need to kind of modernize the process of building embedded software. So the cloud kind of went through the same process where they started using Kubernetes and using containers to push out software to contain the runtimes, to make applications more portable and easier to install. And then what that ended up giving those companies building those applications is horizontal scalability. They could service more users this way. And so that's the kind of modernization I think we're needing to see. And so a little bit what we do at Foundries.io kind of challenges the status quo of like, this is a new way of developing products. It's a secure way of doing it. And then you kind of get to use that foundation that I was talking about, right? Stand on the shoulders of giants, right? You're able to get this foundation from us and then stand on top of it and build your product. So yeah, that's where the status quo is. And it's been slow. I think embedded is the area where it's probably seen the least amount of change over the last couple of decades.
So I want to go into, you mentioning Elon Musk, because I love that guy. Like he's just awesome. To me, he's awesome. A lot of people kind of like hate him. They make him cringe a little bit, but like I love him a lot. And the thing is that when you say kind of him challenging the status quo or him challenging what's going on in the world, is it feels like all of his solutions, his innovations are kind of based around people saying, no, that's impossible. It's too expensive. And then he says, oh, well, if it's impossible because it's too expensive, let's make it cheaper. I'll design something that makes it cheaper. And so then because it's cheaper, now he can do all these cool things like recycling rockets or inventing a new boring machine, whatever it is. He's always making he's challenging the status quo by saying it's not impossible. I'll just redesign it so that it's more cost effective.
Well, and I love people with that personality, because that's what you need to push innovation. When somebody says it can't be done, every really good engineer says, let me think about ways that I could do it, right?
Yeah.
And then you have the crazy ones that are like, I'm gonna go do it. And I think he's straddling that line of crazy enough to try new ideas and fail. I mean, and that's a big part of it, right? Elon Musk failed a lot, but he was persistent and he had conviction in his beliefs, and that I think the combination of all those things drove him to be successful. And that's what I look at as true innovation. When you see something like that where somebody says, no, this is got to be the way it is, or there's got to be a solution, and you push hard for it, and you may not do well, right, off the bat, but eventually, because of your persistence, you push through, and the world around you change the world, right? You don't, the world doesn't change for you, you change it. And I think that's kind of what happened with him. And I don't want to say that that's what we're doing, but it's a similar reference, because we're kind of coming at this problem from a different way. And a lot of people's reaction to that are, I want to do things the old way, right? Because everybody likes to cling on that. And there's nothing wrong with doing the old way. I just think scaling out and making more devices and making things more secure, we need kind of, different tooling and different approaches to solve this problem now.
I love all this. I actually have 2 follow-up questions.
Okay, go for it.
No, but it's like, I don't know which one to go for, right? Because we're going to go in 2 different directions. So I'm excited here. So let me go for the first one then. I think what's interesting, you're talking about innovation and how you need to challenge the status quo. And then you talked about how engineers want to solve problems, right? And I've been finding this throughout my career and in my life in general. A lot of people kind of approach the I think I can solve this and kind of build the product around it, right? And a lot of times that doesn't work. And why doesn't it work? Well, because you're not solving anyone's needs, right? You're just kind of doing something because you can do it, right? So I think the challenging thing and the interesting thing is, am I actually just pushing boundaries, or am I trying to solve someone? And in your case, I mean, the cool thing is that you are solving people's problems, right? And I think that's why that's why you're going to be successful, because you're actually solving the real issue of going through all that work of having to patch your own software that you haven't upstreamed perhaps, and you have to kind of keep on building and doing a lot of work on your own kind of fork of an open source project, right? So I guess I was going to ask you basically your key. I think I heard you say in another interview that running upstream software is the key to security. Can you kind of elaborate on that?
Yeah, absolutely. Yeah, so that's a good point. So yeah, that's kind of our main vision, for myself and Foundries, is the latest software is the most secure software. And I think everybody that works on open source software would agree. They're like, absolutely, right? You hear Greg Crow-Hartman, Linus, you should be running the mainline kernel. You should be running, a stable kernel that's been updated. It has a maintenance plan, and not just fork off the kernel, right? Doesn't make any sense. But I think we all know, anybody that works with Linux, is that's hard, right? That's a hard problem, is to keep up to date. And I think, just going through with the kernel CI project, getting to a point where we could have all this hardware running the latest software was difficult. And so that was a problem that I'm like, if we can make that easy, then we can make the inherent security that you get with doing those updates easier. And that was really the main goal there, is to provide tooling in a kind of managed, hosted way that provides you with the ability to run the latest software. And then by that thesis, then you have more security. So this is kind of similar to, solving a problem in this way is difficult, because people aren't used to managed services and tooling providing them this solution. And so we did it for a couple of reasons. It's easy to scale this out so that many customers can use the same base and use the same set of tooling, and then it also enables them to move at their own pace. So I do realize that a lot of times when you're shipping a product, you have to go through certification processes. So just changing the software and updating it, even if you have the ability, isn't also always something that's able to happen. And so what we want to at least provide is the mechanisms, so that if you did absolutely need to update your product, you don't not have an update system, you don't not have security, and you don't not have a software strategy. And so you get all of this with our product, where we're moving this open source recipe forward. We call the Linux micro platform, and your factory is basically can pull in different releases of this as a customer needs to. So they can have an update ready to mitigate a security issue, and then decide when to deploy it. And so not only does it give them the easy tooling to consume those updates, but it also gives them the control to say, I control my fleet, I control when these devices roll out, and when these software fixes happen. And then another part of that is, so if you want to run the latest software, you got to be able to consume it. So we've solved that problem, but then you need to be able to test it, right? And so being able to consume it, test it, verify, and have the confidence that this fixed the security issue, or there's no performance regressions or functional regressions, and then to be able to have that confidence to roll it out is kind of those other tools and those other pieces that you need to have in place to do this properly. And I think there's very few companies in the world that have made the investment into the toolings like internally to be able to do that in an efficient way. And so that's, I think, where we kind of saw the problem is that, look, there's a huge amount of investment, millions and millions of dollars in engineering that goes into building, these kind of processes that are done internally. And there's not a lot of differentiation as far as that goes. So if we can make a common tooling set to allow all of that to happen, then customers building products can focus more on building their product, making it faster, tuning it more, rather than having to worry about all the infrastructure parts to build it. And so it's a multi-layered problem to achieve. And we just kind of, our approach is always iterative, right? Let's get something out there. Let's get feedback from the customers. Let's iterate it on again. It's like open source software. That's exactly how it's developed. And that's kind of how we do our product as well.
So Tyler, walk us through this whole, you've mentioned standing on the shoulders of giants, right? Like, which giants are you standing on here? I mean, like, if you're referring to the new way of doing things, like, from what I understand, I mean, I remember talking to you and Ricardo and all the folks who are in Foundries a while ago when this was all kind of coming to fruition, right? And everyone's like, well, you used to have to actually walk up to the device, hard line into it, and then update it that way, right? And
Yep.
So if you have a fleet of 10,000, 20,000 units across a pipeline going from East Coast to West Coast United States, and you need to update these devices. So I mean, I don't want to answer the question for you. I'm not sure if that's even the answer, but what's the old way? What's the new way? What are you innovating? What is this? What are you changing? And also, you mentioned testing. Maybe we can dive into kernel CI afterwards.
Yeah, sure.
That one? Okay,
Yeah.
cool.
Okay, so yeah, the old way of doing it. This is actually how we ended up developing our product, is that we were doing it the old way, right? Where we do a Yocto build. And so we assembled this Linux micro platform. This is an open source recipe of that starts with the boot firmware. So you've got like the trusted firmware, you've got uboot UEFI, you've got opte, you've got Linux kernel, you've got open embedded in Yocto, and then, all the packages above that, right? I mean, that's all open source software. We get that for free, and that's awesome. So we assemble it, basically pinning versions down, testing it, making sure it's stable, and then we can deliver that as our base. But we started doing that. So we built this. First off, we didn't have the Foundries factory. We just had this recipe, and this was cool. We're like, hey, we're going to add a secure OTA to it. So we went and did that, and now we can update these devices. Now the problem was, so I wanted to go and take the Linux micro platform and build a marine navigation system for my boat. And another engineer wants to go and build a thermometer for his kids' room so he can monitor temperature. What we had to do was fork that code, do our changes. And then we realized as soon as we forked it, we couldn't update it again because the micro platform is moving forward. And we kind of did a snapshot in time. And so we need to re-merge it back in. And it was a pain because that's the old way of doing things, is you fork the software and then you make your changes and then you have to resync it every single time. And then you get merge conflicts and it's kind of hard to keep it up to date. And that's what we were like, oh, this is painful. And we were having to reflash the devices, right? Like constantly going in there, reflashing the devices build to build. So we decided what we need to do is provide tooling to solve a problem here that allows you to overlay your changes rather than forking the base operating system. So it allows you to remove components of the base operating system or add components, but you're not forking anymore. You're overlaying your stuff on top of a base platform. And what that allowed us to do is we could each have our own little factories doing our own thing and then just bringing the updates in, because essentially we're overlaying on the top. So we can just keep moving this base forward and putting our changes over the top of it. And we got to this point where we're like, wow, this is really powerful because we're all able to build our own products, even though they were just kind of our own use cases at the time. But we're able to maintain them now against the base. And running the latest systemd is easy. I can just pull that change in, apply it, and send it down to my devices. And then we were like, okay, so how do we improve this, right? So then we came up with this idea of tags, which is, if you've ever used Chrome OS, it's like channels in Chrome OS, right? Where they have a developer, experimental, stable channel. And effectively, the source code branches in your factory where you make all these overlay changes, correspond to new tags. So you can have like an experimental one where it's the bleeding edge of the Linux micro platform. Maybe it's the mainline kernel and all the latest software versions. And so you can take a device which is on like your production stream, your master stream, and just move it to the experimental seamlessly without reflashing anything, and pick up all those changes and run the latest software and test the latest software and say, okay, now I've kind of done that. I can switch it back to the production stream. It's back out deployed doing its thing. And so I'll kind of demo this at the end, but now you have this ability to make customized software versions in branches and move devices seamlessly between them. And that's, I think, something that's been a big hit with our customers because they can contain their features in branches. And then like when people are doing code reviews on branches, now, not only can they physically view the code, review the code, they can switch their devices onto the branch that they're reviewing and actually test the functionality of that device. So that's been something that we've found to be very exciting.
It's interesting. You mentioned that you were building something else, and then you kind of figured out actually what I need is a tool, right? It reminds me of Linus Torvalds that like was building Linux and then decided actually I think I need a way of like interacting with the other fellow developers, right? So he just developed Git and GitHub, right? It's like oh my god, like
yeah, because none of the tools were meeting his needs, right?
Yeah,
and
exactly.
do development without the tooling to do it. And so yeah, I don't want to say it's on that level. I mean, I think Linus developing Git he's done a lot more for the industry than we have, but it's a similar idea. Like we had our own problems. Like we're like, this isn't working for us internally. So how are we going to make this and solve a bigger problem here?
And that goes back to what I was saying earlier, like you're actually solving a problem, right? And that, aside from now kind of to broaden the perspective, I think aside from factories, I think that's key in general, right? Like that's building new product should be around like actually solving a need, right?
Well, and it's not only like if people aren't using our factories, right, to do this, that's okay. I'm hoping that in any case, we change the industry so that product developers say, well, we need to be doing this, right? And it doesn't necessarily need to be with a factory, but those processes and that idea of how to run the latest software is instilled in them. And that becomes a part of being, your product development cycle so that it changes the way software is being developed, whether or not, our product's used or not.
I was going to ask you a question going back to the analogy with Git as well. So if you've got different branches, right, of you were saying you got like this experimental branch, and then you've got like your mainline or like the actual kind of production branch. When you merge, I mean, you're still going to have merge conflicts when you go from one branch to the other, are you not?
No. So yeah, that's really interesting. So because of the software that you're maintaining in those branches, that's your software. So you may have merge conflicts, but it's with your own software. It's not with the open source software coming in. And the way we've done this is we've separated the platform software so that can be updated, and there'll never be a merge conflict because the file names, you're not like going in there and changing those files. What you get is basically a way to extend it. And so you have a file where it keeps all your layers and all your software you're bringing in, and you can create a layer on GitHub and bring it in. And then you can do all your work on those GitHub layers, and you can create branches there, and you can create branches in the factory. So really all you're merging up is the base manifest, which will never have a merge conflict because you're not actually modifying that base because you can overlay on top of it. Does that make sense?
Yeah, it makes sense. So you've separated the changeable code from the kind of...
Exactly. And we did that on purpose. We started with the old way where we're like, oh, we'll just put our stuff in that manifest, and then there's merge conflicts right and left, and it's like, well, we want to make this easy. And so for people who don't know Git and how to do merge as well, like that's too much of a barrier. So we actually have tooling now that automates this. So you can literally say, just give me the latest release in my factory, and whatever branch you're checked out on, it'll pull those changes in, and then you just push them. And so that's kind of how our system works, is as the code changes, that's what drives the factory, right? It's very, very code driven. So as the code changes, new builds are kicked off, and then updates we call targets are kind of created. And that's what devices consume as targets. And so each one of those targets is connected to a branch. And then, from there, you get all this flexibility. And what's really neat in some cases, like, for instance, Pelion, right? We have a Pelion integration, and some of our customers are using Pelion to manage their devices. And to begin with, like, we set up a Pelion branch that had all the bits with Pelion in it to connect. And then, we just have the regular branches out there. And so they could take a device that was completely managed by Foundries and update it. And then you're on a device that's now being managed by Pelion, and you can push the update up through Pelion, and it would come back down to the device, and it can move forward in that path too. And then if they wanted to go back, they could just switch it seamlessly. And that was a feature that they were like, wow, this is really powerful, because now we can put our production devices on Pelion, but we can do all of our development in this kind of less more flexible way for CI, kind of like a development workflow, and then go into production with Pelion. And so that's been an example of using these branches to like hold features, and then because you have all those features contained in that branch, it's easy to update that Pelion branch and bring the latest Linux micro platform underneath it, and then bring the latest from Pelion on top, and kind of have this solution that's easily available to the developers.
Did I just hear a rooster?
Yeah, let me shut my window real quick.
No, it's okay. I thought that's kind of cool, actually.
We got a loud rooster here. Sorry about that.
That's the first time I've heard a rooster during a live stream.
You're the first on the show, that brings a rooster in.
Yeah. No, so all of this is really cool, Tyler. I mean, I've of course known about Foundries for a long time now. I'm glad to get this recorded and set in stone, talking about it. But you also created, or I think co-created, Kernel CI. Mm-hmm. Yeah. And I'm kind of interested if maybe you could give us a little bit of a walkthrough as to, like what Kernel CI is. Yeah. And then if at all, I'm sure you're using it with Foundries, because I mean, I see Foundries here on the partner supported list here on Kernel CI. So Alessandro, it's kernelci.org. I don't know if maybe you want to just pull it up and give a little show of the landing page. But yeah, Tyler, and maybe you could tell us a little bit about this and how people could use it, and or how Foundries is using it.
Yeah. So everybody gets the benefit of it right now. If you run Linux, you've got the benefit of it. And so it basically started at Linaro, where we needed to test all this code we were upstreaming needed to get tested. And so I was a tech lead at that time, and it was like, how are we going to do this? And so I looked at the problem, and I said, well, we got a couple problems here. So for one, we have 637 ARM device trees in the kernel, like the 3.0 release. And 3 of the 600 actually boot on hardware. Like if you were to build the kernel for that configuration and actually flash it, only 3 of the 637 device trees I could find actually worked. The rest of them had problems, right? So I said, we have to solve this base problem of all the things we think work upstream need to be tested on hardware, and it can't be emulated because it's specific to the hardware. So we need to get as much hardware as we can and test this every single time the kernel changes. And it's a huge problem because the kernel's changing like 8 patches a second or something like that. I mean, it's an amazing amount of turn. So what we said is, okay, let's, instead of tackling this problem as Linaro, let's create a space, because people are testing these boards all over the place. There's maintainers that test them, and let's get everybody together. Let's have a common language how to report test results, and let's have a common set of builds that everybody uses and agrees on, that these are the test builds. Because you got to lock down a compiler version, you got to lock down a user space, you got to have all these things agreed upon to have a standard platform. And so we started to get agreement with different various groups, and companies started sending us hardware, and we'd have these distributed labs kind of set up all over the world. And so what happens now is we've created a system that will monitor all these upstream branches. So Linus's tree, Next, stable, maintainers. So a lot of the kernel maintainers have their trees monitored by this. And what will happen is every time they make a change, we'll make a build, and then all these jobs get sent out to hardware all over the world, and all these different companies' labs, even some personal people's hosting labs, and then they'll get boot tested. At least that's how it started out. And then they'll send the results back like, hey, did it even boot to a console? So by the 4.0 release, so that was a whole kernel release, we had basically all the device trees booting again, and we could verify, hey, all these platforms that we think work actually work. And the part of the motivation for me was I wanted to run upstream software on my development boards, but there was always the vendor software stacks that were getting, here's all the information. Well, sometimes that configuration of like load addresses and configuration to run an upstream kernel wasn't actually given. So you had no reference on how to do it. And so what, if anything, this is like, you find your favorite development board, you go onto kernel CI, you type it in, and if you find the board there, you have what version of software boots on it, where does it get loaded, what version of U-boot is it running, all those kind of things are there. And so you can go and like replicate, that upstream software on your board.
So this is so in a way, like that example that you just gave right there, this is kind of a way for you to go in a way, it's a little bit of a decentralized or what is it? You said distributed labs, right? So people are putting in their boards, right? And that means that if I want to go use that board, I go check and see if it's already working. Otherwise, I might have to go through some enablement myself if it's not up there.
So an example of that is I was one of the boards that I supported. I'd actually met him at Open Compute. Was a Parallella board, which had this like cool FPGA accelerator on it and stuff. And one of the GitHub issues that I was following came up and like, say, hey, I'm trying to run the mainline kernel. You give me the 4.14 kernel in the vendor drop, but I need new features in the 5.0 kernel. How do I do it? Well, I just gave him a link to kernel C. I'm like, hey, we test this board in my lab. I know it boots. Here's all the boot commands and everything like that. Here's where I'm loading everything. Here's how the images are assembled. And he's like, this is great. It gave me a recipe on basically how to take what I've got and run open source software, like upstream mainline software on it. And so, that the boot testing was good. Like we could basically say, hey, look, it boots to a console, but there's so much more than that now. And so as this became a Linux Foundation project, we've got Google, Microsoft, Foundries, Red Hat, Bay Libre, like we've got a whole bunch of different members in there contributing around this to push testing, right? And so now we're starting to run a bunch of tests as well, like V4L2 subsystem tests, right? Like specific subsystem tests in there to kind of get more coverage now that we've got broad hardware coverage and boot testing. It's starting to drive that in. We also have Clang builds, so LLVM and GCC. We have a couple different GCC builds so we can kind of help the tool chain because all of this is connected, right? And so all these combinations kind of need to be checked. Another really neat thing that's kind of come out of this is, Guillaume, he's kind of the main technical lead at this point. He's from Collabra. They're big, they've been with the project kind of from the beginning. They're really got the Google Chromebook and like the Android team involved in this. So we test the Android project treble trees. And so going back to your first question, Robert, is like, how does somebody use kernel CI? Well, if you run an Android device or you run any Linux device that's newer than a 4.0 kernel, there's a good chance that all of that's been tested through kernel CI, that whole way through that development flow. And one thing that we added to kind of help the maintainers out is automatic bisection. So when there's a regression that's detected, like a boot regression or a test regression, it'll actually go back and bisect the revisions to try to find where the commit that broke the test or the boot, right? So that we can then go back to the maintainers and say, hey, here's the bisection log. If I revert this patch on top of it, it fixes the issue and goes away. Can you please look at the patch? And so they like it because they get kind of instant feedback if there's been a regression in the hardware, maybe something that they changed that was unexpected, that had cascading effects other places. They're able to go and like have it quickly debugged, or at least give them the patch that they can go look at to go, well, why would this break in that way? And so I think everybody that uses Linux, the maintainers are getting value, but then kind of the consumers of Linux are getting value too, because more companies are now inspired to run open source software, and that kind of goes back to the latest software is the most secure software. We got to make sure this is tested so that people have confidence to run mainline kernel. Because back 10 years ago, they thought it was kind of a joke to run a mainline kernel, right? Like as a product company. Now we're starting to see companies ship a mainline kernel, and if we all do this, and we don't have all these out of tree patches, it's easy. It makes the software update story a lot easier because we can just consume and put all of our effort into testing one thing rather than trying to do each one of our variants, right? And that's kind of the idea of kernel CI, is that we all want to see this flourish in products, but we have to get to a base level of confidence with people building products and OEMs that designing them to use the software.
I mean, one of the big things there, though, I think it was just kind of stapled in because of the whole Android device, just how phones functioned from the get-go, right? Like phones are disposable products. You have them for about a year or two and they're gone. So there really was no reason to make those chips, to bring those chips into the upstream, right? Like why mainline them? Why spend all those engineering efforts unless the chip's going to be used for longer? But now, as it seems like, I mean, from what I remember, Qualcomm was one of these first companies where they were like 10 years of support for this cell phone chip. It was the 410E on the Dragon board. Yeah. So now you start seeing companies like that do it. It's like, well, then we should probably be doing this too, because you can get a lot more out of the chip if you keep it around longer, right? You already put all that money into making
the total cost of ownership too is lower, right? I mean, if you look at it upstreaming that chip, once it's upstream and you've switched all your software references to use upstream software, your maintenance part of that, it's really just like, does it continue to work? You just need to make sure you sustain it. At that point, you don't have to maintain it, right? And I think Qualcomm was smart, and they realized that we get this upstream. We don't have to have a team, rebasing our patches, right? It might be painful. The initial upfront investment is there in upstreaming, but once you get over that, the long-term benefits, the total cost of ownership over 10 years of supplying that chip, the software engineering, payroll is a lot lower, and then we can work on our new products. And we don't have to work on that. So I think they saw that as an opportunity to really innovate there, and I think they did a good job. So yeah, go ahead.
So I was gonna say, did you see the new 96 boards that came out yesterday? I think in the morning.
No, what was it?
It's the 865, the RB. I think they're calling it the RB5. A step up from the RB3, of course. But featuring the 865 chipset. I'm trying to find it on the 96 boards website. It doesn't look like it's been.
So I picked up one. This is their new Avenger board, the STM32 from Aero. That's a pretty neat one.
Yeah, that's another one that 96 boards pushed out. Yeah.
And I just picked up the Thor board, which is the IMX 8 version as well. 96 boards are still kicking out boards that are pretty cool and neat to see all the SoC vendors getting involved there.
Yeah. But yeah,
guys,
I mean,
sorry, Robert. No, I was just going to kind of like take a step back on one of the. So we talked about. I think Robert asked earlier about what makes. I guess what was the old way and what's the new way, right? I think we've kind of. We didn't really talk about containers and how that's really moving to embedded, right? I think I find that, I still talk to people that have no idea what containers are in the embedded world, right? And it's quite interesting. I think it's a big shift there is a big shift that's happening, right? It's been there for a while in other worlds, but not really in the embedded world. And I was going to ask you, how much do you see, is it shifting really fast? Like, has it picked up? Is it accelerating now? What do you see?
I do think it's accelerating. I think ARM's commitment to helping get their build hardware out there is really helping, because that was like kind of, I worked on Docker containers in Linaro and Kubernetes ports and stuff, before it was really mainstream. And that was always the hard part. And that's kind of what I brought up to the Linaro members, is that if you want Docker to flourish and you want it to be supported on ARM, you need to give them efficient ways of building the software, because you cannot do it in emulation. It's too slow, or in some circumstances, because it's not actually native, the detection mechanisms for the architecture don't work properly in Docker. And so, I was kind of pushing them like, hey, the Graviton instances, the Packet.NET instances, these are important to get out there so that, PostgreSQL, any of the big kind of container or the big software projects that are building containers that are being deployed, like they got to be able to build the software for those architectures. And so, getting that available was kind of the first step into really making ARM a first-class citizen in Docker. And then as people got more comfortable, and I think it solves a problem in embedded that we've had for a long time, and that's that it contains the runtime, so the application's dependencies and the runtime environment. You can pin it so it doesn't ever change. So that application only gets the environment in which it needs to run. Now, when you could do this on a traditional embedded system where you build that into the operating system, but the problem is if you change those dependencies, or you need to move one up because the platform software needs to be running a newer dependency, but the application requires an older one, then you have a problem, because now you've got to figure out some solution to that that's kind of nasty and messy. Whereas if you had it in a container, it's got its own dependencies and its own runtime, and then it uses the host kernel as the operating system, rather than like virtualization where it has its own guest kernel, and it's effectively an operating system running on top of another operating system, or side by side. So Docker is layered in that approach, which is nice, because you can start to do things like use the GPUs, use ML AI accelerators in Docker containers. You can put all of this software that's like very complex, right? And you don't have to muddy the water with your platform. And what's also nice about that is product developers, right? There's usually a platform team, and what's their job? Make sure to provide a platform to the application developers. And then you have the application developers, and they need to provide the application. They don't necessarily need to know about what's in the platform. And so this actually separates the boundaries. And so it allows those two teams to move and develop software at different speeds, and then can be easily integrated and put together to form a final solution. So, I definitely see that being appealing. And then I think what we're seeing in the IoT and the edge space is a lot of cloud companies starting to push down to the edge, right? Because they realize how important this is going to be. And what do they use to build their services? They use Kubernetes, they use containers, right? They understand these technologies. And so I think that's why we're starting to see a ramp up, is because they're requesting it, and they're going to develop solutions that allow them to do that. And then the industry as a whole is going to kind of take notice and say, okay, maybe we do need to modernize our approach to embedded development. Along with that, there was always a concern that, there's too much overhead with containers to run on constrained embedded systems. So the demo I'll give you today is a 512 meg A8 Cortex A8 running 5 containers, providing routing services with under 128 megabytes of SRAM usage. So you can have pretty complex systems, and you can tune these containers down. I think Alpine Linux is one of the nicest things that's ever come along, because it's such a stripped down version of a runtime. It doesn't use glibc, it uses muscle, but you can make small, tiny containers that are like 10 megabytes compressed, and that makes it easy to deploy over like an LTE connection to embedded devices, and it makes it simple to consume and not use a whole lot of space and resources. So yeah, we can tinify all of this stuff.
Sorry, it's just funny sometimes, like, when I hear us talk, right? Like, but you in particular, the last like paragraph that you just spat off, right? I could picture just someone landing on this broadcast and being like, wow, what the heck were those 20 acronyms that he just used in series? But no, I mean, that's an anecdote. But yeah, no, totally agree. It's amazing. Kind of, I mean, from I think it was not even that long ago, like when Zephyr first surfaced, right? Like when you start getting these like real tiny RTOSes that are going on these the smaller Linux on the smaller devices, right? And it's kind of like a revolution where you're starting to see these IoT devices really start to take off, and the capabilities of these IoT devices really start to take off. Then you get TinyML and all these machine learning things that are getting pushed out to the edge, and so the IoT and the edge. So it's actually really crazy,
Well, that's all these things. Our companies want to get into this because they realize how much data is there, right? And that's the endpoint for data ingestion is going to be the edge, right? And so all of these accelerators, like it's kind of neat to see all these companies coming together, putting these tiny like TensorFlow Lite, right, which runs on MCUs, right, can do ML type processing on a microcontroller. And then any of the big processing loads. So like you have a bunch of TensorFlow sensors out there that are collecting, doing a little bit of machine learning, and then kind of aggregating their data to a gateway, which then does another process, which then hands it up to the cloud to do another process on it. And so you're actually processing it kind of each layer. And it's a really neat thing to see. What's great is it's pushing innovation, because it's like, hey, if we can get this on a smaller device, if we can run this with less power, we can do more, right? And so it's creating an incentive for these companies to jump in there and create innovative solutions on the edge. And it's been really fun to be a part of of this whole revolution.
I'm gonna add one other thing to the mix that I think is quite interesting. So I think we still haven't seen a kind of version of containers on like Cortex-M, Cortex-M devices, like really constrained devices, right? But there is one thing that's coming out that's quite interesting. I don't know how much you know about it, but I'll just throw it out there. WebAssembly. I mean, you think could be an interesting technology that could evolve and actually provide that kind of runtime that you need for.
Give them the acronym though. Give it WASM.
WASM. That's right. So I have to admit, I'm not as well versed on WASM. I've looked at it actually for a couple of blockchain projects who are considering using WebAssembly, right? And I think that's a good indication of kind of where this is going. Is that it does allow you to run like your own kind of host operating system inside of a browser, and that's actually really interesting. It does scare me a little bit about the security implications of WebAssembly, but it's also really, really powerful. And so I think it has the ability to change the way maybe applications are delivered, and I'm all for that. I mean, honestly, being like this whole revolution with web apps where it works cross-platform has been great, because the native applications, like this is SteamYard's a good example here. It works on Mac, it works on Linux, it works on Windows because it just runs in a browser, right? And more and more of that I see, if we can get applications to run cross-platform like that use WebAssembly, that can run on ARM and all the other architectures kind of seamlessly, that's great, because then you can accelerate application development, because you can do the app development once and then put it in a framework and then deploy it into many different architectures and use cases. I mean, that's great. So I'm curious to see if we're going to start seeing customers that want to use WebAssembly in some of their applications and support them. I mean, that's something that we look forward to.
Yeah, and I mean, just to add to that, I think that what's really cool is also you could write in different languages, and it just gets kind of compiled. Like it's just amazing. I think it's an interesting. I don't know much about it, but it really excites me. I think it's something that we'll hear more about?
I think we might. I think we'll see, but I think we might get to see a session on this during the Dev Summit, ARM Dev
cool.
Summit. We don't know, but I mean, like they're still going through the whole vetting process. But I believe someone submitted something like that under the cloud native track, so could be cool to see.
I was gonna just say one thing. I wanted to kind of, and then we'll jump into the demo because I think.
Okay.
But I was just gonna say that it was funny because we invited you to this talk last week, and then basically this week, I think the 15th. So I think that was Monday. This blog comes out where ARM kind of announces this collaboration with Foundries.io publicly, right? And it was really cool to see. So I was gonna basically ask you your take on what we've announced together, and what you think people can actually do with the. I mean, I'll let you talk about it.
Sure. Yeah, no, it was a really fun project to work on ARM with. So, we basically got the requirements from ARM to enable their reference software for Core Stone 700, A5DS, and then the accompanying FVP models that go along with that. So FPGA, MPS3 support is the FPGA that we support in this, and then obviously the fast models from ARM that are provided at that link below. So what we wanted to do is add a couple goals, is that we wanted to create a reference stack in a Foundries factory so that anybody using these new Core Stone virtual platforms or the FPGA platforms could take the pre-built binaries, bring this up to a console, register the device, and then be able to get out-of-the-box demos. So one of them being a Pelion connection, a connection to Pelion, so they could try out the device management side of things with Pelion. They could deploy Docker applications, to the edge, kind of like we were talking about before, is that you'll have the ability to create those applications and deploy them. That kind of provides an out-of-the-box demo. And what's really neat about it is that ARM is in control of this factory. So we've helped them get the software in there, in place. And then as they make new releases, typically when ARM makes new releases, you have to go reflash the board, right? You have to, I got to go and redo this. You don't have to do that anymore. If you keep your platform running and you've registered it, it'll update over the air. And you'll get all the great security features that we talk about at Foundries. But it just shows how we can take an existing software implementation. I mean, obviously, ARM had software for these devices, and we can pull that in and bring it in and create a secure, updatable system on these FVP platforms and on the FPGA. And so if you're a company that's looking at implementing this new IP, it's really great because you can grab the virtual platforms, start them up today, and actually make sure your application software runs on this new architecture. And then same thing for the FPGA, you can get your applications on there as well.
We might want to just say, for the people that might not know what it is, Core Stone 300, Core Stone 700, and other, I guess they're not acronyms, but they're just things that probably most people don't know. They're subsystems, and inside, Core Stone 300 has got the M55, actually, a new Cortex-M processor that has kind of new machine learning capabilities. And then the Core Stone 700 has got actually a subsystem with Cortex-M and Cortex-A together in the same subsystem.
Yeah, it's a heterogeneous coprocessor architecture, and it's what I really like about it, and that's kind of why we got involved in the project. It's very geared and geared to security-related features. So they have some of those coprocessors will bound the system resources. They call it the firewall, where you don't have access to certain things, certain registers, and it blocks you access so that you kind of root the root of trust into the hardware in this case, or the virtual IP, and then from that point up, you're kind of secure. So it's almost like security by design. They built all the things that we need to secure product properly into these new architectures. So we thought it was really important to make sure our software was compliant and work with ARM on the PSA spec and to understand where they're going, how we can be compliant with that, and then how we can provide value above and beyond that by allowing our secure update client and all of that to run on top of it. And then the idea being that if a customer wants to implement this new IP and they have a software solution that they can get right from ARM and from us to start their product development right off the bat with.
Hey, so Alessandro, thanks, by the way, Tyler, for answering all that. But Alessandro, maybe we can get those 2 questions in YouTube and then run to the demo, yeah?
Yeah, I think I was going to say, you just sat back. I thought we were just going to go through the demo. Just like, I'm watching now.
I got 3 monitors in front of me. It's pretty nice at this view.
Can we do the demo first, and then we'll get the questions?
Okay, sure, yeah.
No, just because I'm aware of time. I want to give you enough time to run through the demo. because I think there's going to be a lot of excited people that want to see this working. Because
Okay.
I mean, we talked about how easy it is. I think we just got to show it now.
Yeah, let's dive right into it.
Let me just pull it up.
Yeah.
Let me just share this.
Yeah. Let me know. Can you guys see my screen?
It's up.
It's up. Okay. So I guess what we can do kind of first off is talk. I'll go through the demos of what I've got set up here. So I have a BeagleBone Black registered to a factory. We call it TI because it's got the TI support in it. And you can see here I've got BeagleBone Wireless 01. It's registered to me. It's running a Target 7. And again, I kind of mentioned this earlier. Factory produces targets, and so you can do something like this. You can say target show 7. I believe that's going to work. Oops, target. My bad. And I got to do -F. Factory. Okay. And this what it'll do here is, I know it's just kind of hard to see. Let me make this a little bit bigger. Is that it describes what a target is, and so it says, here's the sources that were used to build this target, and then you have the name of the target. And this is the OS tree hash. So we use OS tree to do incremental updates over the air for the platform. So firmware, kernel, root file system. We use OS tree, and then we secure it with the update framework to deliver it to the device. And then what you see here is you've got applications that are available too. And so we have an open thread gateway application, which I can go through in a second. But basically, a target is a pointer to a platform reference and application references. You can have multiple applications in here. But we provide this tool called Vioctal to actually access and manage the targets that are registered to your factory. So you can look at which targets are available. So I think if you even do targets list and do the factory, you can actually see what available targets there are. And so you can kind of tell here that my device is on 7, so target 7, which means I'm on the master tag, and that there's open thread gateway. And then there's the device that it built for. But you can see that there's 3 other targets here, and they're the Devil-based targets. So it means I've pushed to the Devil branch 3 times, and it's created 3 targets. So I can kind of show you what that looks like here. So like target 9, I enabled WireGuard in NAT64. I'll come to that in a second. And then target 10, I actually merged up a pre-release of our 70, so it's version 71 of the Linux micro platform. So the Devil branch that I've created here is actually running newer software than currently master, which is running our V70 release. So what we can do is we can do a couple things here. So first off, let me just check, make sure no containers are running on here. Okay, so we don't have any containers on this BeagleBone here, but let's say we wanted to first off, put an app on this device that provides the the open thread gateway services. So let's go ahead and do that here. So we're telling it to be on tag master open thread gateway, and we're going to tell it to deploy this open thread gateway app. So what you'll see here, kind of on the bottom, is, let me bring this up a little bit more so you can see it. This is our configuration daemon here. This is the output, and this is our update daemon. So when I push this configuration down, you'll see the configuration daemon actually get a hold of it, and then act on it, and then start to tell the daemon that it needs to put the Open Thread Gateway app on and ensure that we're on the right tag. So let's go ahead and do that. So we push that up. This is encrypted with a public key from the device locally here, and then it's pushed up to the Foundry's factory and then down to the device. So there's security kind of throughout with that, and it's there's no configuration being exposed to the factory itself. So now the device is pulling the 5 containers, which will provide the open thread routing services. And while it does that, we can kind of take a look at this container definition of what this looks like. So this is a Git repository within the factory, and we have an open thread gateway Docker app definition here. And so you can see what we've defined is there's 5 services. There's an interface monitor. There's an open thread WPAN TUND, so it's a daemon that's going to manage the YPAN network. You've got a DNS64 container. That's going to provide routing for the NAT64 module. And then you've got Joule. This is kind of the NAT64 module. It's an external kernel module that's not in Linux, so it's actually built as an external module and included in the build. And then you've got a proxy to proxy the traffic from CoAP to HTTP. So that's what we're deploying, and that's how it's defined. And so as you push changes to these repos, you get new targets created in the factory, and then you can update to them. So let's see what happened here. Okay, so now we've created the open thread gateway. If we check our containers, we should have 5 containers, but that's not all. So what I need to do to actually make this work is to insert an 802.15.4 dongle. I don't know if you guys still see my camera. I think you can, but this is the dongle, and we're going to put it in this BeagleBone Black right now. You should see it enumerate, and there it is. So now we have an open thread device that is plugged in, and we have the containers running. And so what we can do is I can actually connect a wireless 802.15.4 badge to it. So I'm going to go ahead and throw the power on now. This needs to negotiate on the network. It doesn't actually have access to ARM's crypto cell, which is their hardware crypto acceleration engine. So it does take a little bit to join onto the network. So basically what we've done here is we've pushed down a new app that implements 5 different services for open thread routing. And then we've inserted our hardware to actually communicate over the radio frequencies to 802.15.4 to this badge. And then the badge is going to connect through this device, be routed to the internet, and then we can manage it. So there's a lot going on there. I'll stop there for just any questions you guys might have. And then as soon as this connects, we can take a look at the device.
Yeah, there are a couple of questions
Sure.
from the audience, actually. So one is Matthew is asking, what happens if the guest somehow screws up I'll put it up actually, screws up the host networking to the point at which it is locked out or routed improperly? Is that not possible?
So you mean like it like shuts down the Ethernet like interface or something like that?
I guess. I mean, I'm just reading.
Yeah, I'd imagine it's to the point where you can't communicate with it anymore.
Right. So that's actually let's go there. So if that happens for some reason, we have a really cool new feature called WireGuard. And so I think we kind of maybe touched on this a little bit earlier. Is we need remote access to the device, and we need it to like it could be sitting behind a firewall. So if that happens and something screws up the Docker networking, and you need to get in there and actually fix the problem, you can do that. So let me show you how to enable that here.
Yeah, he's also asking like a follow-up. Matthew is asking a follow-up one. He's saying, yeah, is that entirely up to me as the owner of the Yocto sources and the guy making the app, or does Foundries do anything to help me handle that case?
Yeah, so we provide like the rollback mechanisms, right? So if your app gets deployed and doesn't actually successfully deploy, then yeah, absolutely, you can set you as a user can set the thresholds in which it rolls back. Now, if the platform doesn't boot and the watchdog is reset 3 times, we roll back to the previous platform image, and so that you get that kind of provided to you. But you as a user can decide, is it 3 times that the watchdog has to reset before you roll back, or does it get up and maybe networking doesn't work even though it boots? Is that a rollback scenario? And so you can define those things as a user with Foundries Factory. Okay, so let me show you. So what I'm going to do here is I'm going to enable the WireGuard client, which will, so over here, I've got the WireGuard server running. So you just spin up a server. You're in complete control of that server. It's not something we provide for you. We just provide the scripts to make it easy. And when you start it, it registers all the necessary VPN credentials with the factory so that any device in your fleet can be enabled, and you can have remote access anywhere in the world. So let's go ahead and enable it. And you can see down here, the config daemon is going to pick it up, and it's going to act on it. And then it'll connect to the VPN server. So I can go back here.
I think you've got a new fan here. Matthew is saying so many goodies.
Well, this one's really cool. We just landed this feature not too long ago. And so what happens here is that now we've got a VPN entry in XC hosts. So we can actually do something like this, I think. Let's see. And so now I've got a remote shell through basically like a reverse tunnel VPN that was set up on demand. And so this server is like hosted out on the internet. So this is tunneled through my firewall at home. I'm not opening any ports for this. So basically this is how you would get in there and say, okay, well, what's running right now? Look at Docker, and you can see, okay, maybe I need to get in here and actually do Docker logs, and you can see the logs out of the containers and debug from this point here. Okay, so let's see if we got this thing to connect up. I don't think we have. Let me refresh this. I have to restart that anyways. Just due to time here, I want to show one thing. So I'm going to disable WireGuard so it's not on anymore. But I want to show what an actual update is. So I'm going to do the same thing here. I'll keep Open Thread Gateway on, but we're going to switch it to the devil tag, right? So there's target 10 is the latest devil tag, as we saw earlier. So this is actually going to do a full operating system update, and we're going to push it down to the device now. So it's the configuration team has seen the new configuration, and then now here we're actually updating the base operating system. Now this is, again, I mentioned OS tree. This is the actual OS tree operation that's happening on the device, and you can see it's pulling down the new deltas. And so this isn't an A/B update system. This is an incremental update system that's happening here. So basically, it's just going to pull the deltas between the build that I was on and the build that I need to be on, and then apply them. And OS tree kind of works like Git in the sense that each commit is like a history, and so that's how the rollbacks work. So you have a history of where you were, and then where you want to go to. And if the where you want to go to doesn't work properly, then you can always just basically do a git commit git reset -- hard head -1, and then go back to the previous revision that you were working with. So yeah, that's a really cool feature. And then you get all the security. So we use the update framework to provide secure updates down to the device here. So let's see here. I don't know why this is. Here it goes. It wasn't scrolling with the window. So you can see the objects coming down. They'll be applied and committed, and then the device will reboot. And when it comes back up, we can check in with the system. And so as this is going, we can kind of look at what's
and the other thing I think that you didn't mention today while you're doing this, I think if I remember correctly, you've actually got a way of staging commits, right? So like you can kind of test stuff before you push it.
Yeah, I can show that real quick, actually. So if we go back here, you can kind of see there's like a devil branch and a master branch, and like they're at least on the container side, they're the same. But you could add new containers here that would only be available on the devil branch, and the same is true with the platform software. So if you go into here, and like this is meta subscriber overrides, right? You go into Devil and you want to enable new packages, or even a good example, a lot of our customers, they have debug configs, so that on the Devil branch or on development branches, the debug image is built with all of the debugging tools on it. But what's in the production image and master, is the actual production image. So it basically inherits from the production image and allows you to extend and add debug tools. And then when you switch your devices to production, it strips all that out, so you don't need all the debugging tools. And then if you were to take a device in the field and want to debug it, you could switch it back to a development stream, and then you'd have all your debugging tools there as well.
I actually hadn't thought about that use case where you actually use it for debugging, for adding debugging capabilities. That's really cool, actually.
Yeah. Okay. So let's kind of go back through here. So the container was updated to the Devil containers, and then the operating switched over. So now we're just waiting for the device to come back up. Let's see here. Take a second because it's on Wi-Fi. Carl's booting. And when it comes up, you can kind of see up here that it was installing BeagleBone Yocto LMP10, which is target 10, which is on the Devil tag. And so let's see as it comes back up. So it's applied, waiting for a reboot now, and then that's what we're kind of waiting for, is it to come back online here.
While we wait, I'll just put up this question: is there an easy way to spawn a VM to produce your image in Yocto?
Yes. So that's a good question. So let's go back to here, and yeah, this is target 10. This is what we're updating to. So if you want to simulate, if you want to rebuild the exact build, you run these two lines right here, right? So if you have you own the factory, obviously this is all private, but you basically authenticate with your authentication token, and you could pull down this script, and then you run simulate, and it will run, since we build it in a container. So our LMP SDK is what builds this operating system. You can actually run the same exact build as it happened in CI at your desk locally. That's really handy for us when we debug builds. Like I'm sure if you're a developer and you're listening to this, you've pushed code at one point that built locally that didn't build in the cloud due to different environments. And so this actually makes it fairly easy to reproduce a cloud build in the same exact manner that it was done in the cloud locally. So we do have that capability. That's a good question.
Awesome, thank you.
Okay, so we're back up now. Log back in. Let's see who's checked in. Okay, so now we are on target 10, and we've done a full platform update, and this is actually running our latest pre-release of V71. So this is not even a release version of the Linux micro platform now. But what we can see is the containers have persisted. So they're still all here. Let's see if we
do you have like all these boards just next to you running?
I do. Yeah, that's like my job, right? In my life. Oops. Not sure why that's not connecting. Anyways, yeah. So basically, kind of what you saw here was the ability to create new targets, which is Docker apps, and and new platform images, and then be able to kind of like push them down to the devices. And you can do this again fleet wide or per device. So I can show you one other thing here is like how we remove all of this. 'Cause that's something that that's kind of interesting. So there's that, and then we just go here and we just remove this app. So if you wanted to clean your deployment and take off those routing services, that's what you do right there. And then what will happen here in a second is it's going to restart that daemon. It'll pull off all the apps because it says, hey, that's not configured anymore. And then those apps will be removed from the system. So it makes it really modular, and it's actually a great way to test things. So you can kind of roll out applications, run a bunch of tests, rip them off, and then do another set of testing as well. So you can see all of the services coming down right now. So that is the demo. That's all I had. I guess I'll throw it open to questions, and then we can wrap things up. So it's probably, I think it went a little over time there than what I had expected.
Yeah. Also, I don't want to keep you too long.
There's the device. There it goes. It connected. So yeah, this is our LWM to M open thread device. It was routed through the server, but now I'm already tearing down the containers. So it's unfortunate.
Love it.
That was awesome. That was
Cool.
really good. And it all worked. I mean, demo effect didn't play. It's
But yeah, and that's been one of the things that we've been doing like all along is like, hey, we demo like this software. We don't just talk about it. It's real. It actually works. We have customers, running this in production, and it's always important to be able to demo it because it needs to be easy enough to demo, right? And if it's not easy enough to demo, then it's probably we got some work to do there.
yeah. Any final thoughts, Robin?
No, Tyler, thank you, man. As always.
I appreciate the invite. I'm a new ARM innovator, so it's been good
That's
to kind
true.
of get out here, and like get involved a little bit. I've been so busy this last couple of weeks that it's been hard for me to like really dig in. But we're planning to submit. We submitted a bunch of sessions to our ARM Dev Summit, and like we talked kind of yesterday about a BOF potentially. So we really want to get involved and kind of like have open discussions around like IoT security and like updatable platforms and see how we can like work with those communities and like build, standardized systems that everybody can leverage and be more secure and build better products that way.
Yeah, that's true. We didn't mention that at the beginning. Probably should have, Alessandro. Tyler Baker, the newest ARM innovator.
We actually said, I don't even think we said that you're the CTO of Foundries. I think we should rewind a little bit and be like the CTO of Foundries and ARM innovator. I mean, we could stick this at the beginning, right?
That's fine. I did the introduction. It's my fault.
It's all good. It was a pleasure. Folks. This was fun. Let's do it again sometime. Well, maybe we check in 6 months from now and see how much progress we've made on the product.
Love it. Sounds great.
Yeah, sounds great. Well, thank you so much. Thank you all for watching, and thank you, Tyler, again.
Yep.
You've been awesome. And actually, seeing a live demo in like 10 minutes, I mean, that's quite impressive.
Yeah, I mean, we did an operating system update, container update. We tore it all down, and yeah, we're back. We're ready to go again. So that was fun.
How long it would have taken in the old days?
Oh man, well, geez, I don't know. It could have taken a long time. I can tell you that. Over an hour, that's for sure.
Well, thank you so much again.
Yep. Thank you. Thanks for having me. We'll see you.
Take care, Tyler. Thank you.